Francesco Sandrelli from the UK Chamber of Shipping, and I welcome to this webinar on biofouling management, advantage and challenge. The webinar has been organized by different associations: the Royal Belgian Shipowner Association, Danish Shipping, the Norwegian Shipowning Association, and the UK Chamber of Shipping, to discuss the advantage and challenge on biofouling management from an owner and innovator side. We will have the following speaker. First of all, Dr. Mario Tamburri, which is a professor at the University of Maryland Center for Environmental Science, is the chair of the IMO GESAMP working group on biofouling, and will provide us a presentation on the overview of ship biofouling and in-water cleaning, including specific effort and performance testing of in-water cleaning system. This presentation will be followed up by a presentation by Stylianos Papagiorgio, which is the managing director of Lomar Lab and was previously the technical director for Lomar Shipping. His presentation will focus on his experience on the operational and technical side, and there will be also a presentation and a case study by Alicia Botz. Finally, we will have John Loaiza, Managing Director of Biomarine Service. He attended the IMO and is an expert on the biofouling management for IMAREST. His firms provide worldwide service with 18 surveyors on biofouling monitoring, cleaning, and analysis, with the focus on environment and energy efficiency. Please, everyone, shut down the microphone, and if you have any question during the webinar, you can write it in the chat or ask some question at the end. We will have a 20 minutes Q&A question. Before I give the floor to the first speaker, I would like for San from LR, Principal Specialist Environment Technical Director, to introduce briefly a biofouling project that LR is carrying out. Thank you so much.
Thanks, Francisco. Let me start sharing my screen presentation. Right. Okay, I hope you can see my presentation. Yeah, thank you. Yeah, so at LR, we have conducted a joint industry partnership with industry stakeholders, including ship owners, major paint companies, technology developers, and port state controls to understand the risk of biofouling, the risk of managing biofouling, or whether it's a risk for financial or regulatory aspects. This joint industry partnership is now completed, and as a result of that, we learn a lot about the risk different stakeholders are facing, and we managed to find out with some solutions how it can be averted. One of the integrated part, I'm not going to go into very detail because this presentation will be shared so you can read it yourself. One of the integrated solution that we have developed to bind these different services and concerns with the ship owner is the clean hull notation with LR under the eco notation category. That is to provide the recognition and the value to the ship owner of having such measures, and then to have that savings time and money. Simply that this requirement goes beyond the 22-23 guidelines, biofouling guidelines. And to put that into perspective, just a simple illustration of a ship that we have made. This is a tanker with 900,000 tons fuel consumption per year. So we sort of map to see what is the impact of no cleaning versus business as usual, which is you are doing hull and propeller cleaning, and to if you have a clean hull notation, how much you could save, and convert that into a, let's say, a figure without considering anything else, just totally focusing on the fuel cost. We talk it like 640 per ton, and then calculated how much of savings a 5-year life cycle a ship owner can get. And this is excluding opportunity cost of hire and probably EU ETS payments. This is purely based on the fuel cost. And now what we want to do, which is the important part, I think Francisco want me to share in this platform, is what is next. So now we have the work done as what we wanted to do and develop that process. Now we wanted to run it through it to see what are the what are the savings are, what are the findings are. So you probably understood this. So this chart, and this is a very well known graph. This is from the IMO GHG Biofouling publication. And what is this blue color shading area? This is where we think that the potential savings can be done compared to a traditional business as usual hull cleaning and propeller cleaning approaches, which is in some consent, which is a reactive approach. So what we wanted to do is right now is to go through for a trial run based on a clean hull notation and validate this data and how much savings you can do from the fuel point of view, how much GHG saving you can do, and how much compliance you can do from the biofouling management point of view, not just for the 23 guidelines, maybe goes beyond and meeting some regional biofouling requirements such as Australia and New Zealand. And the most important thing we want to bring up from this trial run is to bring that biofouling and the importance of hull fouling and energy efficiency to the energy transition strategy. Because there's not much of, we see lots of synergy between biofouling management and GHG emission reduction. And in the energy transition strategy and going beyond the new fuels, maybe the difference between hull management could be types of fuel. It could be the difference between you are using battery power to a fuel cell to an internal combustion engine. So we wanted to bring this on up to the stage that energy transition needs to take into account the biofouling. And then you also meet in the biofouling requirement from the prevention of invasive species point of view. So now the trial run is open beyond the JIP partners. Anyone interested in participating as a ship owner, as a paint manufacturer, as a technology developer, welcome to contact us. My contact details are there. And we want to do this and bring it to the industry to see how we can collectively manage this challenge. Thank you, Francisco. Back to you.
Thank you so much, San. Mario, do you want to share your screen? We can see it, Mario. We cannot hear you, Mario.
Left it on mute. My apologies. Apologies, I left it on mute. Yeah, thank you, everyone. It's a great pleasure to be here. I'm going to be talking a bit about ship biofouling in general terms, some background, but I'll spend most of my time focusing on work we're doing, looking at in-water cleaning systems as a solution or an approach to addressing ship biofouling. This work has been done under a couple of programs I run through the university. One's called the Alliance for Coastal Technologies Act, and the other is the Maritime Environmental Resource Center, or MERC. But first, just on some background, I think most of you are fairly familiar with these issues, but just to get us all on the same page, you can think about ship biofouling from two different perspectives. Of course, there's the vessel operation perspective, as we just heard, fouling, whether it's microfouling, just a slime layer, or macrofouling, larger organisms like barnacles, can result in increased roughness of a ship's hull, increased drag, of course, and resulting in increased fuel consumption and exhaust emissions. Fouling can also interfere with the piping systems of ships. It can clog fire systems, cooling water systems, and the like. So it's a large operational concern that the shipping industry has been addressing for many, many years. From the other side, though, there's also biosecurity concerns or invasive species concerns, you might say. Biofouling on ships has been identified as probably the most important vector for transporting non-Indigenous species. This figure here is from a publication of a colleague of mine looking at different ways non-native species get moved around the world. And the top two graphs are ship vectors, either fouling on top or ballast water underneath it. And it's over time, and you can see over time it's increasing the number of invaders that have come from these different vectors, and you can argue fouling is probably the most important. These non-Indigenous species have a wide range of serious impacts on local economies, ecologies. They impact social and cultural resources. They cost billions of dollars in harm and mitigation. So it's a big concern from both sides. The shipping industry, of course, has traditionally fought biofouling through anti-fouling systems or coatings. Most prominent now are various coatings designed to prevent macrofouling attachment, things like biocidal coatings using copper or zinc as deterring growth on the surface. These biocidal coatings are probably most prevalent. Around 80% of ships use those, but there are also other alternatives. There are coatings that reduce adhesion of organisms to the surface. They're fouling release or non-abrasive hard coatings. So organisms sort of, if they grow there, they'll get sort of removed, slough off as the ship moves through the water. While these coatings are very effective, they're far from perfect. They typically have about a 5-year service life, but they don't necessarily prevent consistently all biofouling accumulation on all ship surfaces over time. So there are some problem areas. Biofouling tends to increase on coatings as they age, and if ships stay in stationary locations for extended periods of time, if they're at anchorage or they're laid up for some periods. There are also substantial areas on the ship that are more prone to fouling, and that's because they cannot be painted, things like anodes, or they're more prone to damage or scuffing, like the bulbous bow or tug and fender points and anchor chain areas and so on. There are also areas on the ships that are really hard to coat, underneath the dry docking blocks, for example. And perhaps most importantly, there are lots of areas on ships that we kind of refer to as niche areas that are suboptimal for coating performance. So gratings and rudders and sea chests and the like. So because of these limitations, there's been a lot of effort of ways to augment the coatings, make better coatings, or something else we can do in addition to just the 5-year coating cycle. And that's where in-water cleaning comes in. In-water cleaning of ship biofouling has a long history. You could argue that the wooden sailing ship days, we did in-water cleaning through careening. They would pull ships over on its side and scrub the organisms off the bottom of the vessels. Of course, with the advent of steel ships, this became challenging, but there were still attempts to, at the least of the waterline, scrub organisms off the side of ships. With the advent of scuba, the access to the hull became a lot greater, and so there were very simple scrubbing and scraping approaches, done on vessels, and that evolved into more mechanized sort of cleaning with spinning brushes kind of approach. It became apparent, though, as we moved into these sort of cleaning operations underwater, that this might have problems associated with it. These organisms we're knocking off might themselves be alive and cause invasions. And by doing this, we might also be releasing some of those biocidal materials like the copper and zinc I mentioned earlier into the environment, which could cause problems. So this has led to what I like to refer to as a new generation or next generation of in-water cleaning approaches, technologies, and systems that are designed to be a bit more sustainable, perform the function while being less impactful on the environment. And you can think about these in-water cleaning systems as a continuum, but there are two ends of the spectrum. On one end of the spectrum is what we call reactive in-water cleaning, to remove existing macrofouling, again, existing large organisms like barnacles and macroalgae or mussels and the like. And so you're reacting to when they're already there. And this approach is now being morphed into cleaning with capture. So what you can have is a cleaning unit that has spinning brushes or water jets. It can be remotely operated or diver driven. And these things typically have a shroud, a skirt around the outside of it to entrain all the material being knocked off the ship, and then some sort of suction approach to bring that waste material, that debris, to the surface for processing, where the solid material is brought off to a landfill, for example, and only clean water returns back into the environment. On the other end of the spectrum is what we call proactive in-water cleaning, sometimes referred to as grooming. And this is to prevent that macrofouling from establishing. And you do that, again, through a cleaning cart. Again, it can be ROV, it can be diver driven, it can have spinning brushes or water jets. But what you do is you periodically remove the biofilms, that first initial colonization of microorganisms, sometimes referred to as the slime layer. If you wipe that off at some frequency or at some periods when you know it's going to be growing, you limit or you prevent the big things, the macrofouling, from establishing on that surface. I put these little red sort of dots here too because there is technology trying to be developed in areas where it's fully autonomous, almost like a Roomba kind of thing for the side of your ships. Those are still a ways off, but that's where some folks are trying to go. Some of these proactive systems have capture as well. A lot of them don't. The idea is that if you're just removing the biofilm layer, those organisms are ubiquitous. They pose, is thought, relatively low risk of invasions. And if you're doing this very gently, just wiping off the microbes, then you're not going to be knocking off a lot of the coating material that could be hazardous. But what our real questions have been over the last few years is how effective and safe is this activity? How effective are they at removing macrofouling and capturing that material safely? How effective are these proactive systems at removing biofilms and preventing macrofouling growth? And then in both cases, are there any measurable impacts to the environment, to the water quality, or any measurable impacts to the coatings through these activities? You don't want these activities to actually reduce the life of the coating, for example. This is all happening in the context of lots of new regulatory activity kind of bubbling up. I think you probably are familiar with many of these. These are just some examples, and I won't go into great detail on all of these, but it's getting a lot of attention now in the sort of regulatory world. Of course, we've already know about the IMO guidelines that were updated from 2011 to last year that were finalized. Just last week at IMO PPR 11, it was agreed to start a correspondence group focus exclusively on in-water cleaning to provide guidance on in-water cleaning activities. But we know about the New Zealand rules, and we know how ships are getting turned away. We know Canada now has a guidance out there for a couple of years now. Oops, sorry. Canada has guidance out there for a couple of years now on how they propose to do in-water cleaning safely. Australia is coming out with rules soon, we keep hearing. In the U.S., under the Vessel Incidental Discharge Act, the EPA and the U.S. Coast Guard will be addressing fouling and in-water cleaning. California has its own set of rules. Even individual ports, like this example of Port of Bremen in Germany, has rules around what you can do. They say you can only do proactive cleaning so no macrofouling removal on non-biocidal coatings. This is evolving. There's more coming out, but this just gives you a feel that's getting a lot of attention from the regulatory perspective as well. So what we've been trying to do, my groups in particular, is to develop ways to evaluate these technologies in water cleaning systems to make sure that they're safe and effective and can be used in a productive way. We're working sort of broadly with collaborators around the world to work transparently and collaboratively to develop comprehensive, rigorous, but feasible methods and approaches for testing the performance of these systems. We're also trying to provide independent tests that facilitate the maturation of these technologies so they can move into operations, to provide vessel owners and operators with information you need to make smart choices on managing biofouling. The data we produce is hopefully useful for the permitting and approval process. But ultimately, what we're really trying to do is provide the scientific foundation for smart, effective regulations going forward that ultimately protect the marine environment. We've been doing this through not only developing these protocols, but trying them out to see if they work. We don't want to come out with recommendations that fundamentally don't work. So we've been testing systems, both to help them mature and perhaps get approval for use, but also to help develop these protocols, these methodologies. They started back in 2018 with a test of a reactive in-water clean and capture system. You can kind of see the layout here. More recently, we tested proactive in-water cleaning system back in 2020 and 2021. You can see the little cleaning unit going down the side of the ship here. And we have an ongoing set of tests now on a second proactive system. So all the lessons learned from our testing over the years, our working with international colleagues, we came out with a series of specific recommendations going forward for how we should do this in a
meeting
smart way.
seminar.
I think somebody is off mute, but anyway, this paper came out a couple of years ago, and it lists a bunch of recommendations on how we can do this in the right way, if you will. And I'll go through some of these bullets in the next couple of slides. But of course, we want to do independent, qualified testing. That goes without saying. But we also recommend that we stick with quantitative, robust, statistically sound data rather than qualitative observations. And an example of that is you'll hear things like, well, we don't want any observable debris plumes behind the cleaning unit. That's important information. It's worth documenting if you see a debris cloud around the cleaning unit, but it's not quantitative. We don't know what that means. It's highly subjective. You know, how far away are you from the observation? How clear is the water? So we want to focus on measurements that we can get sound numbers to make sound assessments of the systems. That includes water quality sampling at crucial control points to understand what the impacts of the environment are. Is there a release of harmful material, both dissolved and particulate, into the environment? And I'll give you examples of that in a moment. We also need to focus on measurable protective endpoints rather than a % reduction, and I'll explain what that means in a minute as well. And finally, we recommend that we want to stay away from understanding whether the species that we're taking off a ship is native or non-native, whether it's viable or non-viable, and I'll explain why that's important as well. So first, on understanding the impacts to the environment, we propose that you need to really focus on, is water quality changing at a cleaning event compared to the background conditions? And where do you want to sample depends on the type of system that you have. If it has, treatment waste collection, debris processing, and so on, you can sample before and after treatment. But you really want to look at the cleaning unit itself, what's it doing to the local environment, and compare that to background. So this is just an example of one of our tests. This is on a proactive in-water cleaning system without capture. We had a sample hose that collected water right above the spinning brushes, and so we can see if it was having any impacts. We also measured the background conditions, in this case of dissolved copper and particulate copper, but there's a variety of variables you can measure. But we sampled a day before the cleaning event, 2 hours before the cleaning event, 2 hours after the cleaning event, and a day after the cleaning event to capture what the background levels of particulate and dissolved copper were. Then we sampled background levels on the side of the ship, but a long distance away, so it wasn't impacted by the cleaning during the same time during the cleaning event, and that's these blue dots here. And then finally, off the cleaning unit itself is the purple and green dots. Green dots when the cleaning unit was stationary and not cleaning. Purple was when it was cleaning. The quick story here is that, yes, there is a signal. You can definitely see an increase in copper levels, both particulate and dissolved. it doesn't really matter for this specific discussion whether this is too high or a concern or not. My point really is here is this is how you would test the system to see if it's appropriate for use or not. And we can, I'm happy to answer more questions later on about details of how to do that. I also mentioned that we should focus on measurable protective endpoints rather than percent reduction. This is an example from the reactive system that we tested. Don't worry about all this data. It's really complicated. I just wanted to show it to emphasize that this is a log scale for dissolved and particulate copper. And this gray area is the amount of that dissolved and particulate copper going into the waste processing unit. What I want to emphasize here is that there was quite a bit of copper going into the waste processing unit. And if you ask to go for a percent reduction, if you ask that system to remove 90%, 95%, or 99% of that copper material, you're still ending up with quite a large amount of copper going into the environment. So for percent reductions, if you start with a really high number, it's not necessarily protected, even if you go down to 99%. So we want to avoid this percent reduction approach to regulating these sort of activities. This is true also for the amount of biofouling on the side of a ship. If the ship is heavily fouled and you say remove 99% of that material, that last 1% can still pose a significant biosecurity risk. And further, there's been a lot of attention or a lot of discussion around these systems should have a capture efficiency rate that's dictated, or a percent capture rate. The problem with that is, in theory, that sounds like a wise idea. They should capture a certain percentage of the material removed from a ship, but we can't measure that. And here's why. We can estimate the percent cover and the types of organisms on the side of a ship, but we can't measure the amount that's removed. So to understand a percent capture, you have to have the mass captured, and we can measure that. How much is is sent off to a landfill, for example. But we don't know the mass removed. For the mass removed, we need to know how much was on the ship before you cleaned, and then how much was remaining after you cleaned. And these are numbers we simply can't generate. It also needs to be noted that the mass will include not just the biofouling, but possibly coating material and possibly material associated with the in-water cleaning itself, say the wearing of brushes. So it's a great concept, but it's something we simply can't measure in any reasonable way. I mentioned the issue of, let's not get too tangled up in the issue of, are these native organisms or non-native organisms that we're cleaning? Are they alive? Are they viable? Are they dead? Those methodologies and those approaches are something we went through when we were testing ballast water treatment systems, and it's a very difficult mess. These methodologies are challenging, they're very expensive, and they're often really error prone. So we recommend staying away from those sort of analyses. We should really be focusing on presence, absence, and magnitude of macrofouling. When it comes to biosecurity, the most conservative thing is to assume that all these tube worms are alive, and you don't want any of them there, right? When it comes from a ship operational perspective, it really doesn't matter if there's live tube worms inside these cases or not. This is roughness and this is drag, so you don't want them there. Finally, around this issue, if there's concerns about water coming out of a treatment of waste, and you want all those organisms to be dead or rendered inviable or whatever, again, don't get into the ballast water treatment system world. Focus on things like the dose of your treatment, exposure time, and don't worry about analyzing individual organisms, because it's a difficult and often uncertain proposition. When you're thinking about possible harm to the environments, there's ways of measuring this that are really feasible and very straightforward. Again, we want to focus on, are you elevating these conditions above the background? Port environments are typically compromised already, they're far from pristine, and so measure the background and then see if you're getting significantly above that background when you're doing your in-water cleaning. So for the biofouling organisms, we can measure proxies. We don't have to measure the organisms directly. We can measure things like total suspended solids, particle size distribution, particular organic carbon, and dissolved organic carbon. If those are elevated above the background levels, you can say there's likely organisms being released into the environment. If they're not, then you can say the capture is working really well. We want to focus on the biocides and coatings as well. You want to measure both the particulate and the dissolved components because they can both increase because of in-water cleaning, but those are direct chemistry measurements, straightforward. And finally, we also got to remember that the coatings have large amounts of polymers as binding agents in them, and polymers are plastics. So we also want to measure microplastics in the environment, in background versus what's coming off during cleaning operations to make sure that that's not increased as well. All right, all of that information, all that work, all of our colleagues from around the world help contribute to a document that we put out in 2022. It's the ACT and Merck Guidelines for Testing and Water Cleaning Systems. It took several years to put this all together, but what we're trying to do is put out a procedure for that tells us how to test these systems in a standardized, robust way. It's meant for all types of in-water cleaning, proactive, reactive, with or without capture, things that clean holes, things that clean niche areas. It's all covered in this document. What's not in this document, though, is what's standard or performance criteria or requirement. That's up for individual authorities, administrations, jurisdictions to decide. We tell you how to measure it, but others decide what's good enough or not. What's happening now is this document is being turned into an ISO standard. The ISO, International Standards Organization, has a committee on ship and marine technologies, a subcommittee on marine environmental protection, and we developed a working group 13 on in-water cleaning of ship biofouling. There are two projects, so two standards being developed under Working Group 13. ISO 20679 is what I just was talking about, the testing of ship biofouling and water cleaning systems. That standard will probably be out by the fall of this year. ISO 6319 is a broader document on sort of best practices for performing and documenting in-water cleaning operations. It will probably be finished by the end of 2025. Both of these are designed to help the IMO process going forward, especially the new correspondence group that's been established, but also to help support everyone, whether it's the private sector developing these technologies, administrations trying to approve their technologies and the like. The working group has experts from around the world representing the shipping industry, in-water cleaning service providers, agencies, researchers, testing organizations. So I will stop there. I know there'll be questions and answers at the end of all the presentations. My contact information is here, but I'll turn it over to our next speaker. Thank you.
Thank you, Mario. Stylianos, you can share your screen.
Can you see my screen? Yes.
Yes.
Okay, great. So Stylianos, I'll be presenting or co-presenting with Inder. I'm the managing director of Lumar Labs, and Inder is the CEO and founder of Alicia Bots. I'll start by telling you a little bit about who we are and what we do, and why did we meet Inder and liked him. So Lumar Labs is part of a privately owned group called the Libra Group, which is active in 20 different industries, including maritime, where our most known brand is Lumar. Lumar Shipping has been around for 50 years, and as of last year, we've launched Lumar Labs. Lumar Labs is a venture lab. I used to be the technical director of Lumar Labs, have now moved on to run Lumar Labs, which is a place where we can experiment. Our mission is to accelerate the deployment of maritime deep tech, mostly around the push to decarbonize the industry and the push to automate the industry. And we're looking at all sorts of different technologies, mostly working with startups that are evolving new tech and helping them make ways into the industry. How we do it is that we've basically offered our fleet of vessels as a live testing bed, a floating lab for startups to test things. We make sure they do this safely, working with class, with insurance, and other regulators, including FLAG. But in the process, we de-risk technologies, we validate the business model, make sure it's sort of workable from a ship owner's perspective, and then we help them go to market. I won't tire you too much with this, but if you're interested, reach out and we can talk. So in terms of biofouling, I'll tell you my personal perspective. I started young in the industry. As a child, I was cleaning my dad's boat with a sponge. This is not me, it's an AI generated photo, but you get the idea. This was exactly my kind of experience. And I was also racing laser boats, yachting, sort of a small yacht. And one thing was very, very evident to me from that stage is that a clean hull is a fast hull, so you want to keep it always clean. And lasers, we would actually polish them by hand with wax just before we race them so that they would be super sleek. The powerboat was gel coat, and then you would rub the fouling off. And I could see the fouling growing really, really quickly. Like a week in the Greek islands was enough for fouling to start develop. And, I had this firsthand experience of seeing slime grow, and it was quite easy to remove. But if you left it for a week, then it wasn't easy to remove anymore. So, pretty early on, I had this concept that, frequent cleaning is important. When I joined the industry in 2004, it was just before the banning of TBT, and I actually attended a dry dock as a young trainee superintendent, and everyone was talking about a tie coat and the TBT-free paint. I didn't have a clue what they were talking about, but eventually it sort of started clicking. And what I saw there was that from there on, fouling became an issue. But up to that point, no one had really worried, particularly at least from within a shipping company. So we would manage ships and not worry too much about fouling because, that stuff was toxic, the TBT paints. So there wasn't any fouling and there wasn't anything to worry about in terms of biofouling management. But in my career, since starting and until today, I've seen that ships progressively get more and more fouled or more easily fouled. In terms of numbers today, we're probably over-consuming as an industry some 37 million metric tons of fuel because of fouling. Do the math, that's like 100+ million metric tons of CO2 that's been emitted that doesn't need to be there. Plus all the problems just discussed by the previous speaker on invasive species being migrated. And so it's a big problem and it's becoming bigger, and we haven't historically dealt with it, at least thinking about recent history. From operating Lomar's fleet, which at some time was numbering 100 vessels, I had a fair exposure to sort of typical do's and don'ts with running biofouling management operations. So very simply, I would say, keep the vessels moving, don't stay idle, because our coatings are meant to self-polish when the ships move. Obviously, keep out of warm and nutritious waters, because that's where fouling develops faster. Some paint suppliers have services where they can give you risk assessments depending on where your ship is trading or anchored and how likely it is to develop fouling. Useful tools, but you should still monitor your hull fouling. This is our number 3. What you see here is a drawing or a graph from our performance monitoring system at Lomar. We collect noon data, get it analyzed by a third party who provides us with this kind of graphs, where it's using an ISO curve to plot the purple line that is the sort of hull fouling added resistance to the vessel, and this is a bulk carrier that we've had from new building. It was launched in the resistance dropping after dry dock, and then it sort of started picking up again over time. Actually, interestingly, the rating at which it picks up, it's higher than it was before dry dock, probably something to do with the quality of the paint we applied and the way we did it. You can see loads of idle periods in between. You can see hull cleaning events, propeller polishing events, and I'll discuss a bit more in the next slide. But one lesson here is that cleaning frequently but softly helps. We had vessels trading in nutritious water in the Pacific, where we would clean them all the time, and there was no paint left by year 3, and we still had 2 years of operation before first special survey, and no anti-fouling left. And that's where problems get even harder to manage. But yeah, in terms of obstacles to these good practices, diver-related issues is a big one. I've broke them into 3 categories here. One is around availability. You don't always find them where we want them. We don't always find them at a price we want them, and they're not always available on the days we want them, or we just don't have the days despite them being available. They're always not reliable. There's, of course, very good, very professional divers, but there's also not so professional divers that will use the wrong types of brushes and harm the paint, or will just simply clean a part of the vessel and not the whole thing and get paid for the whole thing. And then you've got constraints around safety, where there might be poor water visibility, too strong a current, the draft is too big, the divers can't get there, or there's just other work going on board, like main engine maintenance. And then you won't allow divers to go anywhere near the propeller because that's dangerous to them. And given the choice of fixing your engine or cleaning your hull, you will always fix your engine and not clean your hull. Then you run into local restrictions where for preventive invasive species, you might be banned from cleaning your hull in a particular anchorage or port. And that's frustrating because you might have the divers, the time and the need to do it, and you're not allowed. And then finally, there are commercial pressures with charters or terminals not giving you time to clean the hull or not allowing you alongside and having to do it in the anchorage, but then having to leave to catch the next port or the schedule. So yeah, that are all frustrations. Just going back to the graph I have here on the bottom, you can actually see somewhere here in 2023, there's a sort of relatively good performance that was then followed by a long idle period. During that idle period, we performed hull cleaning, but after the hull cleaning and the idle period, the performance was still worse, and that was a long time after dry dock. So you can imagine that this may have been because of not much paint being left, maybe the cleaning not being that effective, or maybe damaging the coating in the first place. So these are very typical problems that I'm sure a lot of the members have met. But from my perspective, it was always around, okay, how do we move forward? How do we push the envelope and overcome these problems and come up with a better solution? Mario mentioned a bunch of different paint systems that are now available beyond the typical self-polishing anti-fouling. I'm particularly interested in the sort of nanotechnologies and the fouling release systems that are permanently there, permanently prohibiting organisms from growing and keeping the hull sleek. But you can't apply them everywhere, and even with those coatings, from what we hear from and see, they still get fouled. So they need help. And one way of helping them is with ultrasonics. You can basically kill the organisms through ultrasonics, but the transducers and the whole system to do this is quite expensive, so it doesn't necessarily make a lot of sense to cover the whole ship, but you can still use them to cover niche areas like the propeller and sea chests and other things like the rudder. So propellers is quite easy to do. Actually, you fit the sensors on the tail shaft on a ring, and it protects your propeller. Same with the sea chests. And then we're looking at grooming systems, where putting a robot will be safer, more efficient, and not limited by availability and conditions compared to diving. So we're looking at, okay, let's put these things on board. What do they need to do to work properly? The vision is to have a ship that has zero fouling with no biocides and no downtime. That's our holy grail as a ship owner. And we think we can get there by using a combination of ultrasonics to protect propellers and sea chests, hull coatings that are permanent, free of biocides, hard and just need regular grooming. And then that's where the grooming robots provide the solution. We can find autonomous, inexpensive, and permanently on-board robots that provide, in combination with these nanotechnology hull coatings, a system rather than one thing that provides a clean and sleek hull coating. So we've been experimenting, and this is where we met Inder and Alicia Bots, who may take the floor now, perhaps, and tell us what he's been doing.
Thanks for the introduction, Stylianos. And my name is Inder. I'm the founder at Alicia Bots. Alicia Bots is a maritime robotics company focused on building underwater autonomous vehicles for inspections and cleaning. Coming to the subject of hull grooming now, as Mario also mentioned that, hull grooming here, we are referring to the proactive in-water cleaning methods at a microfouling level, as defined, by the IMO, so which is basically cleaning, biofilms of slime, or maybe just a 1 mm layer of algae at the maximum. On the left, you can see a kind of image of what we are referring to biofouling. Next. So we at Alicia Bots, we built a magnetic wheel drive robot, which pretty much moves around the ship's hull in a semi-autonomous way. It's lightweight, weighs only 25 kgs, and it is equipped with mild nylon brushes on the forward and the aft of the robot, which is specifically for the purpose of grooming. It's not designed for cleaning any heavy fouling. It's equipped with 4 high resolution and low latency cameras, which gives a kind of a 360-degree view of the hull for the operator, which also can be live streamed back to the office if there is reasonable internet connectivity. And you can do this while the ship is sailing, preferably less than 11 knots, but it has been tested to work satisfactorily up to a speeds of 17 knots. Next. Here's an example where we have deployed on the Lomar fleet. We usually spend around 4 to 6 hours with the crew, training the crew on the deployment and the operation and how to control. We also in the first attendance, we actually mapped the ship's hull with the robot and define some semi-autonomous paths where it's like a kind of a waypoint navigation on the ship's hull, for the robot. This approach by the crew deploying as and when required, based on their operations, is like minimum disruptions to the operations of the ship, as well as minimum downtime, and the crew has the flexibility to do it as and when they require. Next. Here's a short video of how our robot performs the grooming action. So, all these green patches are basically a kind of, you could say, a 2 mm layer of grass on top of a layer of slime. And robot's mild nylon brushes are effectively, basically removing this this kind of biofouling. So it can the cleaning span is almost 1 meter. So it cleans like a 1 meter lane, and then it changes the lane, comes to the second lane, and this way, for a Panamax sized vessel, it takes anything between 6 to 7 hours to complete each side. Yeah, and this is some of the images of before and after cleaning. Although this is slightly more than what the grooming capabilities are, but nevertheless, after multiple runs, we managed to clean this kind of fouling as well. As of next steps, in the next course of action, what we are trying to achieve is a fully autonomous operations with minimal crew intervention, so that it can be the robot can be just kept in a designated place, and it can operate on its own, and navigate on its own in the entire hull and come back to the same place. We are also looking forward for collaboration with various paint manufacturers, as well as biocide-free paint manufacturers who provide these hard coatings, who probably would require proactive grooming. And I think with the combination, with such a combination, we would have better fuel performance, longevity of the hull, and extend the life of the paint beyond the docking cycle in some cases. Over to you, Stylianos.
So I'll jump in here. So this is one of the latest things we've done with Inder, and we had this vessel that was new to the fleet of Lomar. It was straight taken to the dry dock, and we've painted the vessel with a regular anti-fouling paint, but we've also made 2 test patches from unconventional paint suppliers. You wouldn't think of them as your first source for an anti-fouling coating, but these are hard permanent coatings that are epoxy based or glass flake, and the idea here is to test how these coatings can be kept clean in combination with a robotic grooming system permanently living on board. So we will see. This is just before Christmas, and we are now testing how this will develop over time. But the vision is to have these robots on board as another type of R2-D2 for those Star Wars fans that is there and can autonomously go overboard and have a look or clean things, and keep the crew also hands off in terms of maintaining on a routine, regular basis those new types of paints, clean and performing. So that's the end of our presentation. Thank you for your attention, and looking forward to any questions you have.
Thank you, Stylianos. John, you can share your screen. We can see, John. Thank you.
Can you hear me? Yes. Can you hear me? Okay. Yes, correct. Okay. Good afternoon. My name is John Loaiza from Biomarine Services. I am the manager director of Biomarine Services. We are an environmental consultancy company based in UK, in London. We carry out different services between the biofouling and the water inspections, ballast water service and calibration check, IMO sampling for compliance, and any marine environmental regulatory advice. So jumping into biofouling, we carry out inspections for underwater hull inspections, biofouling risk assessment, anti-fouling conditions, marine growth prevention system, anti-fouling coatings, pre-dive dock underwater inspection assessment for budget planning, forestry control biosecurity inspection, offshore oil and gas biofouling inspection, underwater structure and asset inspection and biofouling, and in water we are applying in the process. We are in the process for biofouling and in water class approved service provider. So, what is the idea behind biomarine services? We use one of the best ROVs in the market for hull inspection. We have a biosecurity platform where we will fill up all the report for the different areas of the ship, whether it's the hull, niches areas, and also will include in our platform the marine growth prevention systems, what are the conditions of them, and the assessment. So it's not just focusing the only biofouling inspection, but also in the different areas that apply in the for biofouling control and management. As everyone knows, biofouling is one of the biofouling together with ballast water is one of the major vectors of invasive species, and it's in areas that we focus to operate. This graph is a little bit familiar now, as it was presented before by Zahan. The idea on this is it shows different strategies that can be applied on a ship to control biofouling. Nonetheless, if you do a periodical inspection according with the operational profile of the vessel, you can find and make some savings. Also, by identify which areas of the ship you create more biofouling and when, and how to clean the ship, to clean the hull and niches areas, and also to inspect your marine growth prevention systems. Biofouling create a big draft of the ship, also create a cost for the fuel efficiency. As it can show in this graph, you can see a total cost. This was done for the operational profile of one of bulk carrier. But this is only one example that shows the increase of fuel consumption. And this can vary for even sister vessels that operate in different areas. You can do the same extra biofouling strategy, but probably two vessels that operate similarly can variate itself between them. And this is because external factors can affect the hull performance, not just even with this with the similar biofouling strategy. So we can just jump this one. So what is assessed during the inspection? So the biofouling is partial inspection. We report approximately biofouling rating levels on the hull section and niches areas. The functionality of the marine growth prevention system installed on the ships. There are different technologies, UV systems, ultrasonic systems, and also the condition of the antifouling coating, hull damage. Together with all of this, biofouling risk assessment for ships is one part of the biofouling management and regulatory compliance for the future. A vessel with biofouling risk profile will reduce the chance to be inspected by poor state control. What that means is, for example, if you have good data and you have a good profile on your risk assessment, you have less chance when a poor state control, for example, Australia or New Zealand, when they come and see a vessel, if you show that you are managing better the biofouling, you may have less risk to be stopped and checked and inspected by them. As you see, this is being increasing now by Canada, US, and will increase with the future. So the better is the ship owners prepared today, the better they familiarize of how to manage the biofouling and how to plan and assess the risk that the ships can create to the local environments, the better it is when things come back into start more regulated. What are the advantages and challenges? Determine the condition of the antifouling systems, such as coatings and marine growth prevention systems. Ship-specific biofouling risk assessment to identify biofouling inspection sequencing. So doing this, you can, for ships, the frequency of ships can vary depending on what is the conditions. So a ship, our platform, we will between inspections create with time some data where you can change from reactive mode to a predictive mode by analyzing what are the patterns of the biofouling growth, identifying which areas you need to focus more to avoid biofouling growth. Also, this provides ship owners and managers decision making and planning in advance how to save fuel. That will be a biofouling predictive tool. Also identify unexpected mechanical damage during the inspection, and reducing the biofouling and having a very good biofouling management that can create, as everyone knows, to achieve the emission targets. There are some use of blends and new fuels, and that will rise the fuel cost for the near future. Also reduce the EU ETS by not having to expend extra fuel. So all those costs compare for the cost that you do to receive data, to put into your system and do a better planning for the future can help you to reduce the amount that you pay for that is nothing compared for the saving that you can generate by doing a good biofouling management. And then also the biofouling guidelines will become mandatory for the near future. So being prepared for that also will help you control this risk. That's for me. Any questions? Happy to share.
Thank you so much, John, and thank you so much all the speakers for the three presentations. They were all three very interesting presentations. I'm going now to open the floor to questions. I'm going to start reading a few questions from the top. Please, if you want to intervene, also raising your hand, you can, okay? I have a first question here by Inder. are there any guidelines for the type approval of an hull cleaning ROV? If not, there is any plan in the future for such type approval? Anyone want to answer this question? John, there is any discussion, Mario, at the IMO level?
Yeah, I think the plan is to have those processes in place. There are documents out there that are going down that path. We're providing guidance on how to test for type approval, but the ultimate process is still being developed. There are groups like BIMCO and I think it was BIMCO drafted a process as well as out there's an industry standard. So there is thought given to it. I don't think anything's formalized yet, and but I think as the IMO process with the updated guidelines moves forward, there will be.
Yes, thank you. I'm reading a question now. I'm going straight away to, there were always in there asking a question to Mario about accessing some document that Mario showed during his presentation, and Mario has provided a link to some of this document. I'm reading a question from Victor. Hi all, I can see the Biofouling GKG report being cited frequently already by two presenters here. I wanted to mention that this study does not consider anti-fouling coating as a variable, and as mentioned earlier, not all coating are created equal. I would like to share with you an extension of this IMO Biofouling study that we did in EMPEL using the ESAT bulk carrier case and the same author as the original study, where were also considered low friction fouling release coating. It is not about doing a regular hull cleaning, but about having a clean hull, and there are different biofouling approaches to achieve that. Any of the speakers want to comment on anything on the type of coating respect on the hull cleaning?
Francisco, Sahan here. I think
Thank you.
not particularly on the coating. I think we all understand that different coatings have a different biocidal effect, and it have impact on a different way. So I think what we're trying to present it here is that in an average, business as usual, or if you do nothing, what would be the cost implication? Business as usual if you do following the coating specification, and what would be the case. I think beyond in future now we have the more proactive cleaning methodologies comes in. Maybe there are some other questions also need to be answered because the compatibility of the coating, if you're using frequent cleaning or hull grooming, how it would impact on a coating. Was there any assessment done? How many times that the proactive coating can actually function before it degrades the coating's ability to perform as a biofouling deterrent? So these are the questions I think in future needs to be asked, because to our understanding, there's not much studies has been done. We also need to take into consideration that the coating and hull fouling is not only impacting on biofouling as an instrument, but also implicated in the CII calculation. So if one side of the regulatory regime doing something that can impact on the other side of the regulatory, so that's the interconnection. So this is why I think all these things becomes more necessary. The approvals, the verifications of the technology, and also the service providers, because this is we believe this is a two-part that needs to go in hand. You need to have a better technology, then you need to also have people who conducting inspection and cleaning also have a certain level of qualification and standardized process. This is why I think this is now becoming a more cohesive exercise. Different parts come together, not just the ship owners, class societies, paint companies, technology providers and cleaning companies and so on and so forth.
Thank you.
If
Thank
I
you,
may
Simon.
just add some comments, Francisco, because you picked up on my comment. For
Go
me,
on, Victor.
I just there. First of all, great presentation for everyone, and thank you for the nice program here today. For me, there are, let's say, some negative effects that you can have by having fouling on your hull, of course, as well documented. And the solution many times is seen to do a cleaning. But we should also remember the negative impact or the risks, essentially, that the hull cleaning may carry, both for the environment, but also for the coating, as was rightly mentioned, potentially for damages, right? And if you, for example, start doing a lot of frequent hull cleanings, I believe one of the presenters also mentioned there was no coating left on the hull after 3 years, then you are running the risk of added roughness. Then you will be incurring higher costs in terms of fuel consumption, and potentially additional cost at the next dry docking, because you will need to be doing additional blasting activity to bring your hull back to the right shape.
Victor, may I? Someone else made some noise, but if I may,
Yes.
discuss here, because it's super interesting, this point. I've actually experimented with a pure epoxy coating that was getting slicker or more polished the more you cleaned it.
Okay.
So, that was fascinating. I have it actually on a boat, and I've had it for 8 years, and it's better and better every year.
This is very interesting.
So the underwater hull cleaning makes it.
But is it the steel surface? Is it the
better.
steel surface, or is it the?
No, this is on a gel coat. But the idea is, can we replicate this on a ship by regularly cleaning? The other advantage I see with regular cleaning, except that you don't allow, more complex organisms to set, and therefore you're not depositing anything invasive, or at least as dangerous in the ports, is that if you do it in transit, you can do it in deep water, and then it's less of an issue, as far as my limited understanding of ocean biology goes. You do ballast water exchange in deep water, you also clean your hull in deep water, and then you throw all the stuff there rather than in port. This is why we're so excited about things like Alicia bots that can work with the ship. We're not depending on services from ashore, but we do it ourselves.
Just a comment on this, and please also welcome Alicia Boat's representatives to provide comments here. But my understanding is that the technologies are very new for now, and they cannot cover the whole hull. So there is an issue. You need to clean the flat bottom, you need to clean the niche areas, and these are essential for the vessel, right? And you also need to polish your propeller. So I guess where I'm leading towards is that, although I very much welcome, and we are testing those technologies also in Hempel, we also see that the divers and the humans in the water, with all safety precautions, of course, taken, are still necessary to ensure optimal performance of the hull.
I agree. We're not there yet. At Lomar Labs, we're looking at what's next, not what's here. But in terms of cleaning, from practical experience, you see that fouling develops along the water line. So it's mostly your boot top or your sort of a vertical flat. I've had vessels for 5 years would never clean the flat bottom, and you take them out in dry dock and they're pristine because it's just too deep, no light, and nothing grows there. So already by keeping your vertical sides clean, you're covering a lot of the problem.
True. It is the early stage fouling usually grows there in the water line, and the vertical sides are the ones that contribute most to hydrodynamic impact for the ship, right? However, you have the biosecurity considerations, right? That you need to consider when cleaning regularly those sections.
Just to add to what Victor said about flat bottom and the niche areas. Yes, I think robotic hull cleaners have certain restrictions. We for example, we cover the verticals, the flat bottom, but yes, the propeller, rudder, and the niche areas are definitely left out, and that's where we emphasize that yes, to some extent, diver cleanings would definitely be required. But I think if you see the future, the next 3 to 4 years, there are going to be more and more robotic companies coming into the space, solving this problem, and it's much more safer operations even for the divers. If you see a recent accident, which happened in Singapore where a diver passed away, so these kind of experiences can completely be eliminated by the use of robotic applications for sure. And second thing is that, at least for the last 1 year, we've been doing, grooming with very mild nylon brushes, I would say. And the impact on the damage to the paint is almost negligible. In fact, with various paint makers, we have done several test patches by rotating the brushes, for 2,500, 3,000 RPMs and checking how much is the wear rate and before deploying these kind of brushes. And that's why we're more into promoting grooming as compared to cleaning heavy fouling.
Thank you. One question, Inder, before for you and for Stylianos. How easy are these systems to be used by a crew? How much familiarization the crew require? And have you seen Stylianos, for example, on board on the vessel, really a proactive use of this system?
Yes, yeah. I mean, to answer your first question, you want to take a pass, Stylianos?
No, go on, go on.
Yeah, so it's how easy it's for the crew. I think it's like it's an experience where you learn how to drive a car. Initially, it looks difficult, but with a little bit of practice, you kind of get there. And it depends. If you see, it varies from each crew, each crew member on its own. But roughly, I think after a couple of practices, they get comfortable in inspections, and then after a couple of months, they even get comfortable to cleaning small patches. And that's where we emphasize that you do regular inspections and you clean small patches of biofouling. That way, you don't have to clean the whole hull at one go.
Thank you.
Yeah, it's also a change management project where, if you're putting these things on board, it's a new tool that's no one ever used before, and they have to adapt to what it is. And anecdotally, we've had comments from crew that essentially they were too afraid to use it because they thought this is something extremely valuable, that if they throw it overboard and it gets lost, then they're going to be in trouble. So you have to work into their minds that, guys, this is something good. At the same time, we have less and less crew on board ships with more and more things to do, and we don't want to add further workloads to their already overburdened lives. So here it's where the ambition of having a fully autonomous system is coming from, where our vision is to have something that lives in a kind of garage on the vessel and just goes out and cleans the ship without anyone ever noticing. Essentially, it's like a pre-planned operation that occurs frequently or regularly, or on a condition-based basis, depending on what our systems allow us to do.
Thank you. Mario, one question for you. Now that we are talking of this more cleaning system underway, one assumption that we had is that if we are doing a cleaning underway, we are outside the internal water. We are reducing the risk of invasive species. Are you fine with this approach from the industry?
Well, it's not for me to decide whether that's okay or not, but I will say that one of the issues associated with in-water cleaning is releasing potentially invasive organisms. Doing it in the coastal waters is more risky than doing it offshore. That's obvious. How risky? How much less risk is there? I don't think we have a good feel for that, but intuitively, yes, it's less risky. But we also have to remember that that's only one of the potential harms to the environment. There's also potentially release of biocides like copper and zinc. There's also the release of microplastics, right? We don't want to necessarily be dumping a lot more microplastics into the open ocean or the coastal waters. So yes, it's probably safer. We don't know, and we have to be holistic when we think about impacts.
Thank you, Mario. John and Stylianos, now we are talking of management, okay? And we have seen there are a lot of technique, there are a lot of coding, there are a lot of technology. Now, the first things that we need to think when we are going to manage biofouling is set up a system of inspection, okay? In both of your experience, how you will start to set up something for an owner, for an organization?
Do you want me to answer? Well, I can start.
Yes,
I mean, it can be quite simple, and I've seen a very practical solution. It was a kind of a steel cart that they had on board, on which they attached a GoPro camera, and with a rope they would lower this on the side of the vessel, and basically record a video of a strip of the hull. And then they would do this forward and aft, port and starboard, every 3 months, and that gives you an assessment of extent of fouling. To actually get the crew to do this regularly on all vessels, despite rotating the crew, it's quite complicated. And this was from a company, not ours, that had the possibility to train the crew and get them to that level. So, and that's like a low-tech solution. Obviously, with AliciaBot or other similar systems that provide video feed, you can then have first-hand inspection results. I think the simplest thing is to look at Noon data and look at this. I forget the ISO number, but it's a well-documented ISO on hull fouling, which tracks how added resistance is accumulating on the hull, and then that can trigger a cleaning event. But if we're talking about grooming, the logic is that you just do it preventively and more regularly, and then you can go into your PMS and just say, I'm going to be doing it every month. I'm going to be doing it every 6 weeks, whatever works. And with practice, I'm sure you can find a sweet spot where it's sufficiently frequently to be easy and not too frequently to be cleaning nothing. If you can implement some condition-based logic into this, talking about maintenance, where you look at the hull and then decide if you do the PMS routine or you postpone it for another 6 weeks, I think that's like the most sensible way of managing it.
Thank you, Stylianos. John, do you want to add anything?
Yeah, I think first of all, you need to do this kind of inspection are very limited and give you a very limited amount of information that you can fit into your system and your strategy. Take into account that to do appropriate risk assessment is not just have a look and take some pictures of some areas. You need to do the risk assessment of the whole ship, including marine growth prevention system, including anti-fouling, any anti-fouling coating in the whole ship, not just in some areas. So I will say also that it's a little bit difficult to know if my understanding is one of the challenges of the industry at the moment is a lot of ship owners take reactive actions instead of proactive actions. So when you come and say that they will require to do an inspection, they will say, well, can you do cleaning? But then when you do a cleaning, you don't know if I go and do an inspection and then I go and do a cleaning myself. Is as I mentioned before, some of the cleaning companies are transparent, some of them are not. So you don't know what information you're gonna get at the end of the day. You can get probably pictures of previous cleaning. You can get pictures for other hull vessels. Some ship owners have experienced that kind of situations. And so if you want to get a properly risk assessment of the ship, if you want to get a reliable information that you can predict, because the idea is reduce the amount of cleaning, but the only way to reduce the amount of cleaning is get the right amount of data. And to get the right amount of data, you need to do a full assessment of the ship condition. And to change that to a predict from the reactive mode to a predictive mode, having a good planning, a good amount of data to predict what's going to happen, which areas I need to treat, which areas I need to focus my attention on. I think that is the right way to reduce grooming, to reduce the amount of fuel that you're going to spend. So in the future, I think that is the right path, not just the hull cleaning. It's a combination of everything. For some ships can be hull cleaning, for other ones can be something else.
Thank you. Thank you so much to all the speakers and all the participants today. For me, it was very interesting. I've learned also myself a lot of new things, okay? And I've seen a lot of things that they will make me reflect more in when I discuss with members. I hope the participants they find it useful, and I really thank the speaker for their time. Thank you so much for today. See you later.
Thank you,
Thank
everyone.
you.
Thank
Thank
you.
you.
Francisco.
Bye.
Bye.
Bye-bye.
Thank you. Bye.
Bye.